Welcome to our third video on the distance formula. Today we're going to look at a little bit more of a complicated example than what we've done before, and we're going to relate the distance formula to the equation of a circle. So here we're going to take a look at the equation of a circle of radius 4 that's centered at the point 3, -1. So the first thing we need to do is plot the point 3, -1. So we come out here, we go 1, 2, 3, and then -1. This is where the center of the circle is going to be. Now it has a radius 4. We're going to draw this circle. So this is the circle that we're looking at. Here's our point here. That's the center of 3, -1. It has radius 4. So what this circle is it's the collection of all points that are exactly a distance of 4 away from 3, -1. So if I pick any point on the edge, that distance is going to be 4. If I pick this point, that distance is going to be 4. If I pick this distance here, that point there, it's going to be 4. All the way around. Now, what we're going to do in order to get the equation of a circle is we need to find out a rule that's true for every single point around here. So to do that, we're going to need to pick an arbitrary point on the edge of the circle. We'll call it xy. We won't specify the number because we need to get a rule that works everywhere. And so if we leave these guys unspecified, they can represent any point along the circle. However, no matter which point I pick, the distance from 3, -1 to that point is going to be 4. And this is where the distance formula comes in, because I can use the distance formula and say that no matter where I pick this point, that distance is always going to be 4. So let's write down the distance formula real quick. Okay, so there's our distance formula there. And what we're going to do is we're going to make the center the x1, y1, and this arbitrary point that we picked out here that could represent any point around the circle, that's what we're going to call our x2, y2. The x1, y1, and x2, y2 are just how they work in this formula here. The d is just going to be the distance here between the center and that point on the edge, which because this is a radius 4 circle, that distance will always be equal to 4. So we can plug 4 in for d, and then we get the square root of x2, which is our x here, minus x1, which is the 3 squared, and then we'll add, and we'll have y2, which is the y, minus the y1, which is -1. When you substitute in a negative number, you should always put it in parentheses so that you can resolve the sign correctly. Y minus -1 will be y plus 1, and we'll end up with 4 is equal to the square root of x minus 3 squared plus y plus 1 squared. Usually when we have an equation like this, we don't want to have a square root in there. It doesn't look as nice. So we'll square both sides here, and we'll get 16 is equal to x minus 3 squared plus y plus 1 squared. And that will be the equation of this circle. So what this equation is that this formula here tells you a rule that's true for every single xy point around this entire circle. And so that's pretty much it for our first example today. What we're going to do now is we're going to see if we can use the distance formula to find a formula that works for every single circle, no matter what the center is and no matter what the radius is. So instead of using a center of 3, -1, we want to have a formula that works no matter what point I pick as the center. So we'll introduce variables here, h and k, and the radius we also want to allow to be anything. So instead of using a specific number like 4, we're going to use the variable r and try to do this exact same process again, but just with an hk as the center and r as the radius. So if we redid this entire problem here, and we wanted to find a general equation for a circle that had a center at some point hk, the radius of that circle is r. Again, we're going to pick a point out here, xy, and we're going to use that distance formula once again. And remember, this is based again on the Pythagorean theorem. That's where this formula comes from. Here, we'll use the center as x1, y1, just like we did in the example a minute ago. And we'll use this guy as our x2, y2, just like we did a minute ago. The distance is going to be this radius value. So this will become r is equal to the square root of x2, which is just our x, minus x1, which is the h. So x minus h. Now, it might seem a little funny that I'm just plugging in letters for letters here, but these letters mean something to this example, whereas these letters here meant something to a general distance kind of thing. So they're kind of standing in for concepts as well as numbers. And so that's why we're kind of using the same formulas over and over again, but with different letters. We're trying to emphasize other ideas. Anyway, we have this x minus h squared, that's that part. Then plus our y2 is going to be the y over here, and our y1 is going to be the k. So this will be y minus k squared. Now, that's pretty close, but again, we want to avoid square roots if we can. So just like our last example, we're going to go ahead and square this equation, and we end up with r squared is equal to x minus h squared plus y minus k squared. And so that right there is the equation for a circle. And this is actually a general circle. This is a circle of radius r and center hk. And sure enough, if we were to do our previous example again and happen to have known this formula, we could have plugged in 4 for r, 3 for h, and -1 for k, and gotten the exact same equation we had before. So the advantage of this is that this helps us see a couple of things. Yeah, if we just memorize the formula, we could just plug things in and we'd be done. But seeing where the formulas come from kind of give you insight into what it is that you're trying to do. Remember, this equation here was based on the distance formula, and the distance formula, as we saw, was based on the Pythagorean theorem. So this equation here on the circle is all dependent on the fact that the Pythagorean theorem is working in all of those possible different triangles. And that ends up actually being a key idea in places like trigonometry. So understanding the background of where this formula came from is actually pretty helpful in understanding some of these things. That's it for our third video in our distance formula series. In our next video, we're going to talk about how you use the distance formula in more interesting locations than just doing a plug and chug kind of computation. And we'll actually see how it's one of the most important formulas in all of mathematics. You can check out that video here, or if you'd like, you can see a more general interest math video from our channel here. If you like this video, please click like and subscribe to Scholar Sauce. We have tons of great content coming up and you don't want to miss out. And we'll see you next time.